In the previous video, we've seen how we can use double integration to work out an area. So in this video, we're going to work out this area here, where this line here is your cosine, and this line here is your sine. So we're going to work out this area here. Remember, we can use single calculus to work out this area, but we are just practicing for later on when we move to triple integration. Okay, so in the previous video, we've seen that the area is given by dx by dy, or we can work with dy by dx. So in this case, if we want to move, if we want to move in the y direction, then this is going to be y equals something, and then x equals something, and then x equals something. So we're looking at the inner integral. We are moving parallel to the y. So that would mean we start here and then we stop here. We start here and we stop here. We start at the sine graph, because this is the sine graph. We start at the sine graph. And then we stop at the cosine graph. And then we are scanning from 0 to the intersection of the two. So where is this intersection of the two? So where is it that cos x equals sine of x? Remember our unit circle. Let's say this has an angle of theta. Sine is the height. Cos is the across. When would the height be the same as the across? Well, that it would be the same when it's at 45 degrees. So basically we are doing it at from 0 to 45 degrees. So this area is given by this integral. So we are now currently here. So let's just evaluate this now. So looking at this, look at the inner integral. When you integrate it with respect to y, this is just a 1 here. So when you integrate 1, it would just give you y from sine t. From sine x to cos x, from sine x to cos x, and then we would put this into here. That would then give you this. Take away, put this into here. That will then give you this, from 0 to 45 degrees. And then integrate this with respect to x. That will then give you this. Integrate this with respect to x from 0 to 45 degrees. And then we would put this into here, sine pi over 4. Well, 45 degrees, you should be thinking about a height of 1, the across of 1. This is root 2, so sine is really 1 over root 2. So sine pi over 4 is 1 over root 2. And then put this into here. That would be cos 45 degrees. This is cos here. That would be 1 over root 2. And then take away, put 0 into here. That would be 0. Put 0 into here. That would be 1. And then tidy this whole thing up. The area is given by this. Okay, so you can use double integration to work out an area.